Error and exception handling. Managing unexpected events is critical for software stability. To ensure your programs continue running when problems occur. Exception handling affects every production application. Without it, even minor issues can crash your entire system. What is exception actually? What is exception handling? Error response, program protection, common examples. For those, the process of responding to anomalous conditions during runtime prevents termination when unexpected situations occur. Common examples are zero division by error, like division by zero, file not found, and memory allocations issues. How exception handling works: detection, throwing, catching, handling. These are the steps we follow. Runtime environment identities issues during execution. Throwing. Program signals that an exceptional event has occurred. Catching. Special code blocks intercept the exception. Handling the program executes alternative actions or recovery steps. Types of exceptions: runtime exceptions, logical errors, environmental exceptions, resource exceptions. Here, in runtime exceptions, there are included that occur unexpectedly during program execution. It occurs with the execution of the program. Null pointer references, array index out of bounds. These are the reasons the exception occurs. Logical errors result from flawed programming logics. Infinite loops, incorrect calculations, environmental exceptions caused by external system failures, network disconnections, database unavailability. Resource exceptions occur when system resources are exhausted, memory limitations, connection pool depletion. Exception handling benefits: program continuity, enhanced robustness, improved maintenance, better user experience. Pro- Program continuity prevents application crashes and keeps system running. Users experience fewer disruptions, reduces unexpected terminations by up to 10-90%. Systems recover gracefully from problems. Makes debugging easier with detailed error information. Developers troubleshoot fast. Better user experience. Provides meaningful error messages instead of crashes. Users understand what went wrong. Implementation approaches. So here, try catch blocks. The most common pattern for handling exceptions. Finally, blocks. Ensure cleanup operations always execute. Create application specific error types. Track and monitor issues systematically. Coming to an example, try block. So please enter the two inputs here, number one and number two, the result. So here we are gonna divide them. So here, if there any error, it goes to the accept value error. In a sense, if the input contains other than numbers like strings or boolean type, it doesn't run the code and it enters the accept value error and print please enter only numbers. So here except zero division error block contains that if the input is given by zero, if an input is given as zero, it goes to the except zero division error and prints cannot divide by zero. This is an error. Else, and after all these block executions, it goes to the else statement and print result is result. What was the result? If divide, what is the reminder of that? And finally, if this blocks executes or not, the finally block will be compulsory executed. So from these key components are try block contains risky code, catch block handle specific errors, alternative actions provide recovery, finally ensures cleanup happens. This pattern ensures your program handles errors gracefully while maintaining resource integrity. Exception handling in real world. E-commerce. Payment processing failures. Recovery graceful. Users can retry or choose alternative methods. Healthcare. In healthcare, critical systems remain operational during failures. Patient data stays protected and accessible. Financial applications. Transaction integrity preserved despite network issues. Money never disappears during errors. Thank you.